Final exam practice paper, page 3. So for question 13 here, we want to state our domain and our range. For here, function of x is the square root of x squared minus 9. So we don't need to draw it, we just need to state our domain and range. And we think about our square root. We can't square root a negative number. So our square root of x squared minus 9 must be, our x squared minus 9 must be greater than 0. So our x squared must be greater than 9. So our x, we square root both sides, we're going to get positive and negative 3. So it must be less than 3 and greater than negative 3 here. So we know for our domain, our x is in between negative 3 and positive 3, and we know we could have the square root of 0 is equal to 0, so they can be equal to negative 3 and 3. So now we think about our range. Well, we know that it can't be negative. We know that square root of anything can't be negative, so therefore y must be greater than 0, or our function of x must be greater than 0. And then we think through the numbers that we actually have in here. So our x numbers are only going to be between 3 and negative 3. So the largest number we can get out of this is going to be 3. So our range here will be between 0 and 3, and they can be equal to those numbers. So next for question 14, we've got 2 to the power of 2x times 3 to the power of x minus 2 is equal to 16. We think about, well, here we've got to the power of x. We can put those terms together. So here 2 squared is 4 to the power of x times 3 to the power of x, and then the negative 2 will be 3 to the power of negative 2, or divided by 3 squared here, is equal to 16. So we can put these two terms together. So we can have 4 times 3 to the power of x divided by 9 is equal to 16. We multiply our 9 across, we've got 16 times 9 will be 144, is equal to 4 times 3 to the power of x, so 12 to the power of x. We know that 12 squared is 144, so x will be equal to 2. Moving on to question 15. We've got quite a lot of different terms here, or numbers in our brackets here. Our first step we're going to look at here, we have this squared. We're going to put this through everything before we start to work. Negative 12 squared, a, we've got to the power of 2 multiplied by 2. B to the power of negative 3, we're multiplying by 2 because we have this squared on the outside here. We've got 4 squared, a, so it's the power of 1 times 2, it still becomes a squared, and b to the power of 2 times 2. So here negative 12 squared gives us 144, a to the power of 4, b to the power of negative 6. Here on 16, a squared, b to the power of 4. So now we can start to simplify this. So 16 times 9 is 144, so we divide by 16 we get 1, divide by 16 we get 9. So here, a to the power of 4, a to the power of 2, we're going to make it minus 2 here. We could bring our b to the power of 4 and make this b to the power of negative 6, negative 4 more. Would make more sense to bring our 6 down, and we're going to add 6 at the bottom here. So we're going to get 9a squared divided by b, 4 plus 6 is 10. Or we could write it as 9a squared b to the negative 10 there. Okay, so for number 16, we're looking at a few different terms here, and we're going to look at them separately. We'll look first here. We know our log base 2 of 64 is equal to something. So 2 to the power of something is equal to 64. 2 to the power of something equals 64. We know, well, 2 squared is 4, 2 cubed is 4 times 2 is 8, 2 to the power of 4 is 8 times 2 is 16, 2 to the power of 5, 16 times 2 is 32, 2 to the power of 6, 32 times 2 is 64. So here, 2 to the power of 6 is equal to 64, and our log base 2 of 64 is equal to 6. So now we can substitute this 6 in here. We're going to have 2 to the power of negative 4 times here times 6. And we're going to think about this through. We're going to say, well, here 8 is 2 cubed for over here. So we're going to have, well, 2 cubed power 2 on 3. And that's the same as 1 on 3. So 2 to the negative 4 multiplied by 2, and we've got here we can multiply across the top. 3 times 2 gives us 6, 1 times 3 gives us 3. So here 6 divided by 3 gives us 2. 2 to the negative 4 times 2 squared here times 6. So now we're going to have here 2 to the power, we've got minus 4 plus 2 is minus 2, times by 6 is the same here as 6 divided by 2 squared, or 6 on 4. We simplify, divide 2 will give us 3 on 2. Next, for question 17, we're going to be differentiating implicitly. So we need to think about each of our terms here. So we're going to differentiate each term. We'll write it through just to make sure we get this right. We want our d on dx of x squared plus d on dx of 3y squared minus d on dx of 2xy is equal to d on dx of 6. So we'll start with our two easy parts. We can differentiate with respect to x, our x squared, and we're going to get 2x. Here our 6 is going to be equal to 0 here. So these are our two easy parts here. Here now with 3y squared, we can differentiate with this with respect to y here. So we differentiate with respect to y. 2 times 3 is 6y, 2 minus 1 is 1, and then we multiply here by dy on dx. And then our next bit gets a little bit more complicated. We have to separate it into two bits. We've got 2x times y. So here we can look at this. We can differentiate our 2x and we end up with 2 multiplied by our y. So that's our chain rule there. And we can also differentiate our y with respect to y. Will give us 1 times our dy on dx, all multiplied by this 2x, which is our other term. There's our u and our v. So now if we put these together, we've got 2x plus 6y dy on dx minus 2y, and then we've got here 2x minus 2x dy on dx here is equal to 0. That should be in there. So now we can put our terms together. So we're going to put our dy and dx terms on this side. We're going to have 6y dy on dx minus 2x dy on dx is equal to here 2y minus 2x. We put these together. We're going to have here 6y minus 2x dy on dx is equal to 2y minus 2x. So therefore, dy on dx will be the 2y minus 2x divided by 6y minus 2x there. We can simplify this a little bit because we see that all of our numbers are even. Divide by 2, divide by 2, divide by 2, divide by 2, we get 3. So now we've got y minus x on 3y minus x. Here, y minus x on 3y minus x, and we can make these x terms positive if we want, so we can have x minus y on x minus 3y. So now moving on to question 18. We want to find the nature of stationary points and inflections. So here we have y is equal to 1 on 3x cubed minus 2x squared. We want to use the tests and sketch the curve. So first of all, we're going to find, well, dy on dx. Here, a third times 3 is just 1. x squared. Minus 2 times 2 is 4, and 2 minus 1 gives us x. So now, to find our stationary points, we said our dy on dx is equal to 0, x squared minus 4y is equal to 0, minus 4x is equal to 0. We can take x out the front of x minus 4 equals 0. So x is equal to 4 and 0. Now we can look at our second derivative here. Our d squared y on our dx squared here becomes 2x minus 4. So first of all, we'll go through with this one. We're going to say, well, when d squared y on dx squared is equal to 0, 2x minus 4, we might have a stationary point. So 2x is equal to 4, x is equal to 2. May be a stationary point. May be a point of inflection, sorry. So to check if it's a point of inflection, we need to test our points around it. So we're going to have our x and our d squared y on our dx squared here. We've already tested our x is 2, gives us 0. We want to try for 3 and for 1. So we substitute here for 1, 2 times 1 is 2, minus 4 gives us minus 2. Then here we substitute in our 3, 3 times 2 is 6, minus 4 gives us 2. So we have negative and we have positive here. So we do have a point of inflection. So our point of inflection is at our point x is 2, and if we substitute all of these, x is 2 into all of this, we should end up with y is minus 5 and a third. So now we're going to come back over here. We've got our x is 4 and 0. We'll start with our 0 case. When x is 0, our d squared y on dx squared. Here is 2x minus 4. 2 times 0 minus 4 will be negative 4. So negative will be a max. So we're going to have a max at the point 0. We substitute that in here and y will be 0. So now over here we're going to look at our point where x is equal to 4. Our d squared y on dx squared, so 4x is equal to 4, and this one was 4x is equal to 0. So here it's going to be 2 times 4 is 8, minus 4 gives us 4. So it's positive will give us a minimum point. So a minimum point will be at the point 4, and we substitute 4 into all of this, and we should end up with minus 10 and 2/3. So these are our main parts of our curve here. We want to try and draw this in. We know at 0, 0 we have a max, and we cut through our x and our y axes here. We know here we have a point of inflection when x is equal to 2. So we got 1, 2, 3, 4. So 2 is a point of inflection with y is equal to negative 5 and a third. So we'll say here's minus 5, so it's going to be down here somewhere. That's our point of inflection. So here this is our max point of inflection, and we have a minimum at 4 and minus 10 and 2/3. So here's minus 5, minus 10's down here. So we have a max, a point of inflection, a min, and our curve continues.